Welcome to True Projects. In this video, we are going to explain about a project titled Seismic Bumps Detection Using Machine Learning. In a groundbreaking initiative, we embark on a transformative journey to tackle the threat of seismic bumps, also known as rock burst, which pose significant danger to mining operation and underground structure. To combat this hazard, we are harnessing the immense potential of machine learning. Our goal is to develop a cutting edge predictive model that can effectively detect and forecast the seismic bump in the mining environment. Through the integration of the advanced algorithm and the extensive seismic data, this pioneering project gives aim to revolutionize the approach of this monitoring. The primary goal to safety and the risk management strategy for the miners and the underground structures by mitigating the potential consequences of this unpredictable event. By utilizing the machine learning technique, we aspire to provide the valuable insight that empower the informed decision making within the mining industry. The implications of this undertaking are far-reaching, potentially saving the life, optimizing the mining practice, and creating a safer environment for all those involved in the mining operation. With the power of technology and the data, our endeavors stand to make a profound impact on the mining industry, safety standards, and overall efficiency. With the objective of advancing the monitoring capability, our project aims to develop a comprehensive and a robust system through the application of various machine learning algorithms. We plan to employ the diverse set of methods including logistic regression, SVM, KNN, naive-bayes, random forest, voting classifier, AdaBoost, and CatBoost. By harnessing the power of these advanced algorithms and utilizing a wide array of seismic data, our primary focus is on creating a highly accurate predictive model for early detection and classification of seismic bump in the mining environment. The key aim is to significantly enhance the safety measure by providing the timely warning to the miners and the underground structures, allowing for the proactive risk mitigation strategy. By subjecting this algorithm to rigorous evaluation and optimization, we aspire to identify and the most effective combination of the model for detecting the seismic bump, thereby fostering a safe and more reliable mining environment. And the project will have far-reaching implications, contributing to saving life, minimizing the mining hazard, and ensuring a sustainable and a secure future for the mining industry. With an advanced and comprehensive seismic monitoring system in place, mining operations can be conducted with heightened safety measures and greater confidence in handling the potential risk. These are the basic requirements that are needed to build this project. Software requirement: Python IDEL with version of 3.7, Anaconda with version of 3.7, and Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this, we need to import the necessary libraries and packages that we'll use throughout the process. These libraries include popular machine learning frameworks like sklearn, pandas, NumPy, matplotlib, and Seaborn, which will enable us to perform the data analysis, visualization, and model building. And the second one is importing the dataset. We gathered the seismic bump dataset, which contain the various features such as shift, Genergy, G+, GD energy, GD+, hazard, NBumps, NBumps2, NBumps3, and of many more. This dataset will be used for training and testing our machine learning model. And the third one is data visualization. Before building the model, we perform the data visualization to gain the insight into the dataset. We create various plots and graphs to understand the distribution of the data identify any pattern or correlation among the features, and visualize the class distribution to check for the data imbalance. And the fourth one is building the model. Here we need to build the machine learning model for seismic bump detection. The first one is logistic regression, and this we employ the logistic regression as one of the foundation model. Logistic regression is a popular binary classification algorithm suitable for scenario where we need to predict one of the two possible outcomes, such as presence or absence of seismic bump. It operates by calculating the probability of sample belonging to a particular class and then making a decision based on the chosen threshold. And the second one is SVM. It stands for Support Vector Mission. It plays a crucial role in this project as it is a powerful and versatile algorithm capable of handling the binary classification task. Its primary objective is to find the best possible hyperplane that can separate the two different classes with the maximum margin, ensuring a clear distinction between the seismic bump occurrence and non-occurrence. This aspect makes the SVM particularly effective and the scenario where the data points may not be linearly separable. And the next one is KNN. KNN stands for K nearest neighbor. Here it is simple and the initiative classification method that relies on the majority class of its K nearest neighbor to predict the class of the new data point. KNN is particularly useful when there is a spatial relationship among the data points, making it valuable for capturing the local pattern and identifying the cluster of seismic bump occurrence. And the next one is Bayes. Bayes is a probabilistic algorithm based on the Bayes theorem. Though it seems relatively simple compared to other algorithms, it plays a significant role in the classification task and certain aspects of our project. It estimates the likelihood of the particular event based on the presence of the other events, assuming that each feature is independent of the other, which it is called naive. Despite this assumption, Bayes perform well in the including certain aspects of our seismic bump detection. And the next one is random forest. Random forest is an ensemble learning strategy will incorporate the powerful algorithm that builds the multiple decision tree, each on random subset of the data, and combines their prediction to improve the accuracy and reduce the overfitting. In the context of seismic bump detection, random forest is effective in capturing the complex relationship between the features and identifying the key pattern that contribute to the presence of seismic bump. And the next one is voting classifier. Voting classifier is an ensemble approach where we combine the prediction of multiple models to make the final decision. By incorporating the different algorithms like logistic regression, SVM, KNN, Bayes, and random forest, each model vote is given equal weight in determining the overall prediction. This ensemble technique aims to enhance the overall robustness and generalization of our seismic bump detection system. And the next one is AdaBoost. AdaBoost is also an ensemble method that will improve the performance of the weak learners. It trains a sequence of weak classifiers, giving more importance to misclassified sample and subsequent iterations. By iteratively adjusting the weight of misclassified sample, AdaBoost focus on challenging the cases leading to the improved accuracy in the final model. And the next one is CatBoost. CatBoost is a gradient boosting algorithm that is particularly effective in handling the categorical features, which can be common in seismic bump detection dataset. This algorithm optimizes the handling of categorical variable, resulting in more accurate prediction. By leveraging the CatBoost, our project aims to benefit from its ability to handle the categorical data and its potential to provide the better accuracy compared to the other gradient boosting algorithms. And the next step is accuracy comparison graph. After training and evaluating all models, we create an accuracy comparison graph. This graph helps us to visualize the performance of each model and identify the most accurate one for seismic bump detection. And the next step is training the model. With the model selected, we train it on entire data set to make the most of the available data for the best possible performance. And the next one is user gives the input. We develop a user interface using the Flask framework, allowing the user to give the input new data or query the model for the prediction. And the next step is the given input is pre-processed for prediction. The user provided input is pre-processed to ensure it aligns with the format used during the model training. And the next step is trained model is used for prediction. The pre-processed input is fed into the trained model which predict the presence or absence of the seismic bump based on the provided feature. And the last one is final outcome is displayed. The predicted outcome is displayed to the user through the interface, providing the valuable information for the potential risk assessment and the decision making. And the execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of various files within it. The CatBoost info folder containing the CatBoost learning algorithm and its training. And the static folder containing of the CSS, JavaScript, images, web fonts files within it. And the template folder containing of the HTML document that are used in this project. It typically include the files like home, index, results, sign in and sign up documents within it. And the app is an py file which contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a pickle file which contains the algorithm information. This file can be loaded into the project code during the runtime to utilize the trained model for various tasks such as making the prediction on new data or performing the specific operation. And the notebook is an IPYNB file which contains a combination of code, graph, output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And seismic bump is a data set in a CSV format that is used in our project. And the test is an testing data set that will be used for the performance of the model. And the sign up is a DB file which appears to be the database file used to store the user information. And to execute the project, we build a Flask framework as of front end. And the overall code of this project is present in the notebook file as a combination of the code, graph and output all in one place. And for the execution, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to first change the location of the disk as to F because our code folder is present in fdisk. Then we write a command cd space and paste the code folder path. By this, we change the directory to the code folder path and then click on enter button. After this, we need to write another command that is python space app.py. By using this command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues and then click on enter button. After running app.py file, the local framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser. And I prefer use Chrome. And here I am pasting this link and then click on enter button. Here and this is the page we redirected back. Contents of the sign up button. Click on the sign up button. Here we redirected to the sign up page containing the necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it redirected back to the sign-in page containing of the username and password. We need to fill these details as username and password as of admin and then click on sign in button. Here it redirected to the index page containing of some input features that are need to be filled, and I'm filling that of seismic of 0 and then 0 and the shift is 0 and the G energy with 15180 and the G pulse of 48 and the GD energy of 72 minus 72 and GD pulse of minus 72 and the hazard of 0 and the N bump of 0 and N bumps S2 of 0 and N bumps 3 of 0 and N bumps 4 of 0 and N bumps 5 of 0 and energy of 0 and then max energy of 0 and then click on submit button to predict the seismic bump. And here we predicted as non-hazardous state. In this way, we can predict the seismic bump by giving the input detail. And then click on back button and refresh button. Here re-enter the details. To predict the seismic bump. And this is the comparison graph where x-axis represents the score of each algorithm we used in this project and the y-axis represents each algorithm's name that are used in this project. And in conclusion, our project has made the significant stride in revolutionizing the mine safety and risk management by leveraging the diverse machine learning algorithm including the logistic regression, SVM, KNN, Neopase, Random Forest, Voting Classifier, AdaBoost, and CatBoost. We have successfully developed a comprehensive and accurate seismic monitoring system. The predictive model showcased the impressive capability in early detection and classification of seismic bump, providing the timely warning to the miner and the underground structures, thereby enabling the proactive risk mitigation strategy. And this project's significance lies in its potential to save the life, optimize the mining practice, and create a safer environment for all involved. As we continue to refine and expand our approach, we envision a future where advanced machine learning techniques play a pivotal role in ensuring the sustainable and secure mining operations, fostering a safer and more efficient mining industry worldwide.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.